Hi everyone. In this video, we'll be looking at the M+2 peak and learning about what the significance of recognizing the M+2 peak is. So the M+2 peak is a peak in the mass spectrum which is two mass to charge ratios higher than the parent ion peak. It is important to note that it is higher because of the +2. The reason why we observe the M+2 peak is because of the presence of two relatively abundant isotopes of a particular element. Let's quickly review what isotopes are. Isotopes are atoms of the same element, but with different mass numbers. They must have the same number of protons because they have the same atomic identity, while they have different numbers of neutrons, hence their different mass numbers. The molar mass of an isotope is going to be equal to the relative isotopic mass, which is based on abundance. So the significance of the M+2 peak is that it is a telltale sign of the presence of chlorine or bromine. And the reason why that is because both atoms contain two common isotopes. 75% of chlorine exists as the chlorine-35 isotope, whereas 25% of chlorine exists as the chlorine-37 isotope. The molar mass of Cl, which we find in the NASA datasheet, is equivalent to this relative abundance, so 75% times 35 plus 25% times 37, which equals to 35.5 grams per mole. If we look at bromine, we can see that both bromine 79 and bromine 81 exist in a relatively comparable abundance. Bromine 79 makes up 51% of the abundance of bromine, while bromine 81 makes up 49% of the abundance of bromine. To calculate the molar mass of bromine, we take their abundances and multiply them by their mass numbers again to work out that the molar mass of Br, according to the abundance of its isotopes, is equal to 79.98 grams per mole. Here we have an example of the mass spectrum for the molecule chloroethane. The mass spectrum shows relative intensity versus the mass to charge ratio. Here we can see the molecular ion peak at this value of 64, and we can see that there is an M+2 peak at the value of 66. Knowing that this is chloroethane, what the M+2 peak therefore is going to correspond to is the molecule of chloroethane which contains the chlorine-37 isotope. This means that the M+ peak coincides with the chloroethane which contains the chlorine-35 isotope. Looking at the mass spectrum, we can also notice that the relative intensity is equal to the relative abundance of the isotope. If we remember from our previous slide, around 25% exists as chlorine-37, while 75% exists as chlorine-35. We can see that the M+2 peak is approximately 1/3 of the size of the molecular ion peak. Looking at bromoethane, we see the same circumstances. The existence of two isotopes with comparable abundances leads to two peaks which reflect their relative abundances. Bromine 81, if we remember, makes up approximately 49% of the bromine isotope, while bromine 79 makes up 51%. We can see that the relative intensity of these peaks reflects the same isotopic relative abundance. So this means that this second peak, at this about 110 range, is going to indicate the M+2 peak, or the bromoethane, which is going to contain the isotope bromine 81. Let's have a look at this example. The question reads, a series of preliminary tests on a small water-soluble organic molecule were conducted. The infrared and mass spectrum of the unknown molecule are shown. Note, two parent ion peaks are shown. Draw the structural formula for this compound. So it's important to note that the question hints to you that there are two parent ion peaks, and these are labeled 152 and 154 in the mass to charge ratios. This means that the compound is suspected to be halogenated with either chlorine or bromine, and as usual we'll begin by analyzing the infrared spectrum, and what we should immediately recognize is that there is a very defining functional group in this 1680 to 2000 range which indicates a carbonyl carbon. Furthermore, we also see that there is a broad signal in this 3200 kind of range, which indicates to us that there is a carboxylic acid. The fact that there's a carboxylic acid indicated by this peak is supported by the fact that we have a peak in the 1680 range, as we mentioned previously, indicating that there is a carbonyl carbon. This is the peak that helps us distinguish whether or not this compound is an alcohol or a carboxylic acid. There is a peak at 45 on the mass spectrum, which indicates the presence of a carboxylic acid. This is consistent with our suspicion after analyzing the infrared spectrum. So that means our formula will be CnH2n minus 1 X, where X is our halogen, O2. What we can see next is on the mass spectrum, there is a peak at 107 and 109. The relevance of this is that these two numbers are exactly 45 away from our molecular and our M+2 peaks. This is further evidence that our compound is a carboxylic acid, meaning that 107 and 109 are the masses of the chain that does not include the carboxylic acid, CO2H. 107 and 109 is going to be Cn-1, H2n-2, X, where X is our halogen. We can substitute our suspected halogens into X in order to work out what N is for C and H. So let's try Cl first. Chlorine exists as either chlorine 35 or 37. If we subtract 35 and 37 from 107 and 109 respectively, we get Cn-1, H2n-2 equals to 72. In this case, there is no number which we can fit into the formula in order to satisfy this equation. Therefore, we eliminate the chance that it could be Cl. And next we will test for bromine. If the halogen was bromine, bromine exists as either 79 or 81. If bromine is in the compound, Cn-1, H2n-2 is going to equal to 28. If N was equal to 3, our formula C2H4 is going to have a molar mass of 28 grams per mole. That means that N equals to 3 is consistent with what we see in our mass spectrum. So now we know what the formula is. If N equals to 3, our formula will be C3H5O2Er. This formula indicates to us bromopropanoic acid. However, at this stage we still have not finished because it asks us to draw the structural formula of this compound. Unfortunately, bromopropanoic acid can exist in two forms. It can either exist as 2-bromopropanoic acid or 3-bromopropanoic acid. What we need to do is we need to search for what is a distinguishing feature of each of these isomers. What we notice first is that if there is a fragmentation that occurs in this position for 2-bromopropanoic acid, we should expect that there is a peak for the methyl group. And the methyl group will have a signal in the mass spectrum for 15 mass to charge ratios. Although it is small, we do see the presence of a methyl ion, which occurs due to the fragmentation of the larger molecule. This is evidence that the compound is 2-bromopropanoic acid, as 3-bromopropanoic acid does not contain a methyl fragment. Therefore, we're going to draw our final compound structure, which is going to be 2-bromopropanoic acid. And our answer is now complete.
Hey everyone, if you found this video helpful, smash that like button and don't forget to subscribe. Want even more? Become a Patreon member for early access to videos, exclusive Discord discussions about questions on chemistry and physics, and live preparation sessions for your exams. Don't forget to head over to our website for topic tests and practice exams to further improve your understanding and learning.